Hello everyone, I am Aniket Guchait, third year, fifth semester student from Computer Science and Engineering Department. For today's presentation, I have chosen the topic Network Flow Algorithm. So to know about network flow algorithm, we have to first understand the flow network. A flow network is a directed graph that is used to model any physical flow like water on pipes and current in wires. We have to acquire knowledge about some important terms like source, sink, capacity and bottleneck capacity, flow, augmenting path, and residual capacity. Let me make you understand about aforesaid topics. Here A is the source and B is the sink. A source vertex has all outward edges, but it has no inward edges, like you can see for the vertex A. But a sink has all inward edges but no outward edges, like you can see for the vertex B. There are also present 5 more vertices. These are all capacities of every edge. The capacity is the weight attached with any edge. The chosen path is called augmenting path. And the bottleneck capacity of a path is the minimum capacity of any edge on this path. Here for this augmenting path, the bottleneck capacity is 3 because it's the minimum in this path. Here the term is called flow capacity term. Here the 3 is flow and 12 is the capacity. The residual capacity equals to the original capacity minus current flow. Let's have a look on mathematical analysis. We can represent flow network mathematically like this: G equals to inside the bracket capital V comma capital E. The non-negative weight capacity is represented by capital C inside the bracket small u comma small v. Here the flow is the real valued function such that if such V cross V tends to R, the capacity constraint is the flow must be less than equals to the capacity. The net flow from source to any vertex, any chosen vertex, is the summation of the flow inside the bracket source to any vertex, and the vertex should be belong to capital V. Now our problem is to find out the maximum flow in the flow network. So to solve this problem, we will use Ford-Fulkerson algorithm. Let's understand the Ford-Fulkerson algorithm using this flow network. Here the S is the source and the capital E is the sink, and there are also 4 vertices. At first, set flow of all edges 0, like this, and the term is flow capacity term that I have discussed before. Now select a random path, like I have choose this path S A C E. If flow equals to 0, then we have to choose the minimum capacity. Here in this chosen augmenting path, our minimum capacity is 3. Let's understand this equation. Flow equals to flow plus bottleneck capacity. Initially the flow is 0. If we implement this equation in this path, we can revise the term like this: 3 by 3, 3 by 4, 3 by 5. Now we have to block the path where the residual capacity will be 0. For the edge from S to A, the residual capacity is 0. For A to C, the residual capacity is 1. For C to E, the residual capacity is 2. So we have to block the edge that is from S to A. We are representing this blocked edge by red color. Now we have to find out the net flow of this flow network using this equation. Net flow equals to net flow plus bottleneck capacity. Here, for this chosen path, the bottleneck capacity is 3. So first, the net flow equals to the bottleneck capacity, 3. Choose another path and repeat the algorithm. Let's choose this path, S, B, D, and E. Here the bottleneck capacity is 2. So after implementing the equation flow equals to flow plus bottleneck capacity, we can get these revised terms: 2 by 8, 2 by 9, and 2 by 2. For S to B, the residual capacity is 6. For B to D, the residual capacity is 7. And for D to E, the residual capacity is 0. So we have to block the edge from D to E like this. We have to remember one thing, that we have to cover all possible paths in this network. Now in the net flow term, we have to add 2, current bottleneck capacity. Let's choose the last possible path. Now we have to find out the minimum capacity. For S to B, the capacity is 6. For B to D, the capacity is 7. For D to A, the capacity is 7. For A to C, 1. For C to E, 2. So the bottleneck capacity for this path is 1. Now we have to implement this equation, flow equals to flow plus bottleneck capacity. After implementing, we are getting these revised terms. You can clearly see, for the edge from A to C, the residual capacity is 0. So we have to block this path and we have to 1 in net flow. Now the net flow of this flow network will be 7. We have successfully found the maximum flow for this flow network. The maximum flow for this flow network is 7 using Ford-Fulkerson algorithm. Now have a look on use cases of this algorithm. Water distribution through pipes, bipartite matching problem. Side by side I have shown this problem. Circulation with demands and cricket elimination problem. I have taken references from JavaPoint, Programiz, and Princeton University blogs. Thanks a lot.